Okay, let's talk about proteins, the third of the four groups of organic compounds. So proteins are really the most versatile of the organic compounds. These things do everything. These are, again, oh my God, sorry. These are the most versatile. All right, they can do everything. These are your doers, okay? They create function. So for example, they act as enzymes, they act as receptors, they act as channels, they produce pigments for skin color, okay? They can harden your hair, your skin. So they do quite a few things. In fact, it's often said that all life is made of proteins, okay, or by proteins. So they're quite a critical group of organic compounds. Now, all proteins are composed of, so the building blocks of proteins are amino acids. And these amino acids, again, structurally, all amino acids will have a central carbon attached to an R group called the variable group, attached to an amino group, here, this is the amino group, and attached to a carboxyl group. So you have three groups, and this one's always H here. So you have three groups attached to the carbon, an R group, an amino group, and a carboxyl group. And there are 20 different amino acids. And they only differ based on the structure of the R group. Okay? So they differ based on the R group that's attached there. So I want you guys to know, for me, I want you students to know the abbreviations for the 20 amino acids. So know their abbreviations. Things like lysine is LYS, glycine is GLY. It's not very hard to actually remember these things. Valine is VAL. Okay, tryptophan is TRY. Okay, so know for me, please, these various three-letter abbreviations for each of the amino acids. They used to be more complicated, but they simplified it, in the past decade or so, even earlier than that. Then also, of the 20 amino acids, there are 9 of them which are called essential amino acids, meaning that you have to bring them into your diet. You cannot make them. Okay, so diet is the only way to get it into your body. Okay, so I want you to know these 9 as well. So it includes things like lysine, your phenylalanine, threonine, valine. What else we got here? Leucine, isoleucine. Okay, so please memorize these 9 of the 20, which are essential amino acids, and then the remainders are non-essential amino acids, meaning you can make them in the body. Now, when proteins are being formed, they are formed as amino acids become linked to other amino acids to what's called peptide bonds. Okay, so proteins are formed in amino acid 1 attaches to amino acid 2 to amino acid 3 to amino acid 4. Okay, and each of these bonds here are called peptide bonds. So let's show you where these peptide bonds form. So let's just do one bond there. So let's go with again, carboxyl group out here, the R group, and the amino group. Over here again, the carboxyl group. We've done this before, by the way, so this should be getting more familiar to you, hopefully. R group and the amino group. So you go in, pull off the water, like so, and then put a bond across there. So then you get your so this right here is the peptide bond. It's always in the same exact spot, okay? It's always between the amino group and the carboxyl group of one to the other amino acid. And it's formed by dehydration synthesis. So as you accumulate these amino acids in a chain, we can name these peptides, these growing peptides, okay? So things like a dipeptide means that there are two amino acids that make it up, right? Tripeptide, as you can think, right? That's just 3 amino acids. You eventually get what's called oligopeptides, which are around 8 or 10 or so to 15. And then your polypeptides, around 15 plus. And then once you get to what's around 50 or so, we call those proteins, typically, right? Around 50 plus amino acids. So you just keep piling them on one at a time by dehydration synthesis until they're big enough to be called a protein. Now proteins have 4 levels of structure. So structure of proteins. The primary structure of a protein refers to the order of the amino acids. Order of amino acids. So for example, it could be valine, linked to tyrosine, linked to alanine, linked to cysteine, linked to threonine, for example. So that order with these 1, 2, 3, 4, 5 amino acids is not the same as this order. Okay? Even though it's the same components, just by having a difference in order here, it gives you a different protein. So the sequence of amino acids, remember you only have 20 amino acids, and proteins can be thousands of amino acids long. So all you keep repeating these things in different orders. So the primary order tells you how they are arranged in the protein chain, okay, the peptide chain. Then your secondary structure, indicated by 2 and that small degree sign. So secondary structure is caused by hydrogen bonding between neighboring amino acids, okay? And this kind of bonding typically creates 2 types of shapes of the protein chain. It folds like this, call this an alpha helix shape, okay? And we have, here you can have hydrogen bond like this across, hydrogen bonds, that kinks the chain like so, okay? Or you may have it like this, and this as well, let me see. Like so, alright. Not very well done, but like that. Then you have the H bonds like this across there. Okay. So it's called a beta sheet folding. All these hydrogen bonds that can kink the chains together this way or kink it this way. The secondary structure, and it's critical. Once you lose this kind of structure, the protein stops working. If it's an enzyme, it's basically denatured and will not do what it normally does. Now, tertiary structure are a bit more complex folded, like so, for example. Okay? Or maybe like this, kind of thing like that. That may create a pore. Okay? So this kind of folding is due to R group interaction. So different R groups in distant parts of the chain will fold around on each other to create these massive kinking or folding of the protein to give more structure there. And the fourth order of structure is really only happens if the protein is built in pieces. So subunits can come together. For example, we may have this subunit will join with this subunit, which may join with this subunit, and so here now it's functional. Okay, so this is the fourth order structure, and it only happens if subunits combine to create a functional protein. But not all proteins will have a fourth order of structure because not all proteins are made in pieces. Okay, all right, we'll stop there.